So this source transformation will be helpful when the circuit contains the multiple sources. It may be the voltage or the current sources. If you want to reduce the network into the simplest one, we need the source transformation is required. So this is where we can reduce a complicated network can be reduced into the simplest form, and we can have the single voltage or the current source in series or parallel with the resistance we'll be having here. First, let us look into the source transformations. First one is we have the different types of transformation. We are going to convert the voltage source into the current source here. So we are going to convert the voltage source into current source. Let us have the let us say the concept behind this one is the application of the Ohm's law, where we are going to convert the voltage into the current here. So this is the resistance R. So we can convert this into the current source in which the current is in parallel with the resistance will be there. So this is where we are going to apply. And here we need to take care about the polarity of the sources. We need to take care. So the positive should indicate the head of the current source, and negative indicates the tail. And the value for the current I is equal to the V by R as per the Ohm's law. So this is the first kind of transformation. It is called as V to I transformation. So similarly, we have the second one, which is called as the current source into the voltage source. We can do it here. So the here itself we can do it here. The vice versa. Let us take a current into the voltage source. So here we have the current source. Usually for the current source, the resistance has to be connected in parallel. Why? Because if the resistance is connected in series, the same resistance will flow. The same current will flow through the resistance, and it does not have any effect. The resistance will be not having any effect. So here we are going to replace with the voltage in series with the resistance. In series with the resistance, we are going to have in series with the resistance. So this is the voltage. V is equal to, so it is I into R as per the Ohm's law. Tail head of the current source will denote the positive, and the tail denotes the negative one. So this is how we can convert a current into the voltage source. We can do convert. So similarly, we can transfer the voltage sources which are connected in series. We can transfer here. So let us see how the voltage sources which are connected in series we can transfer here. So here we are going to consider the voltage source. For example, assume that we have the multiple voltage sources which is connected in series. So here we have the assume this is a positive, this is say V1, and this is negative positive, so it is say V2. So I'm going to denote the polarity here. So this one can be replaced with the single voltage source. So here for the addition of the voltage sources, here the polarity should be same here. Plus minus should be there, so that we can add the voltage sources we can add into the single voltage source. So this will become the positive minus. So V is equal to it's a V1 plus V2 we can write. Suppose if we have the other kind of circuit elements where the voltage sources are connected with the opposite polarity, it is connected with the opposite polarity. So then we need to take the difference of the voltage sources we need to take here. So assume this is the polarity we are connected. Say this is plus minus with the V1. So this is with the plus minus with the V1 we are connected here. Say minus and this is plus. Say this is minus and the plus V2 is connected. Again the plus and minus V3 is connected. So this one we are going to replace with the single voltage source, which is having the value. Say this is the polarity of this one depends on the maximum amplitude. So the polarity time being I'm going to retain like that only. So this is depends on the individual voltage. We can define the polarity. So V is equal to since V1 and connected with the reverse source, so that is V1. So you can see minus and minus are connected in series here. So we need to take the difference of V2, and again the plus and minus it is being connected. So we need to add the V3. So the polarity of this one depends on the maximum value of the V1 or V2 which is 3. So the polarity will be defined. That's why I left the polarity like that only. So like this we can add and subtract the voltage sources which are connected in series connection. So similarly, we have the different methods of connecting the current source also. So if the current sources are connected in parallel, many current sources are connected here. So we can add the current sources. So like this, if the current sources are connected parallelly, so say I1, so I'll take the condition of the same polarity and different polarity in the same circuit. So we are going to have the I1, I2 and I3. So this is I2 and this is I3. So we can replace this one with the single current source where it is equal to the I1. The same polarity current source we are going to add. So I1 plus I3 is the same polarity current source minus the opposite polarity. Sorry, the opposite polarity is I3 is the opposite one. The same direction is the I2 and I1. So we are going to add the same polarity and I3 is the direction of this one depends on the value of the I1 and I2 and I3 depends the polarity of this one. That's why I left blank like that only. So this is how the different current sources which are connected in series and parallel we can do replace with the single one and single current are the voltage sources. So similarly, if for the current sources, always the resistor has to be connected in parallel, and for the voltage sources, always the resistor has to be connected in series. It has to be connected, and we are going to simplify the circuit based on the concept here. So this is how we can perform the source transformation. We can do perform here. The other concept is there where if the circuit is very complicated, so we can perform the concept of the source shift. We can call that is called as a E shift and I shift you are going to call. Let us look into that condition here. So I'm going to consider the E shift. I'm going to consider that E shift is also nothing but the voltage shift here. So this is called as the source shifting you're going to call here. So let under the concept of the source shifting. Source shifting, we are going to shift the sources into a different one. So under this one, the first one is called as the E shift you are going to call here. For example, if let us consider the circuit contains the current voltage source like this, which are the many multiple branches are there, and we have the multiple branches like this. So this is the multiple branches where we have the resistance R1, R2 and R3 is connected. The resistance R1, R2 and R3 are connected. So this is we have the resistance. Let us say this is nothing but R1, R2, and this node I'm going to call it as a and this node I'm going to call it as a B. So this is R3, R4, and R5. So here we can shift this is the voltage source. We can shift the voltage source towards the node A or else towards the node B also we can shift here. So these are the two kinds of shift we can perform. So the first shift is I'm going to shift the voltage source towards the resistance R1 and R2. So this can be done like this. Let us have a look here. So this is called as the source shift or E shift we are going to call. So here I'm going to shift towards the node A. We are going to shift towards the node A here. So at this time, this will become the node A and this will become the node A. And this is the resistance R1, R2. So here the resistance, this will become the node B at that time. Here we have the resistance R3, R4 and the R5 will be connected like this. So this is R3, R4 and the R5. So this is the one kind of shifting the source. The polarity of the voltage source will remain same thing only. So this polarity is plus minus, it will remain same only. So this is the one kind of shift here. The other kind of shift we can perform, we can shift the voltage source towards the resistance R3, R4 and R5. We can shift the B here. So let us have a look into that one. So two ways we can shift that one. So here we can shift that into the method which is called towards the nodes B we can shift here. So here I am going to shift the voltage source towards R3. So this has become, and I'm going to shift towards the R4. We are going to pull and we are going to shift towards since I'm holding B and I'm going to shift here, the voltage source will become like this in series with this one. So this is the resistance R5. Since I'm shifting here, this is minus and this is plus and this is the V. So the voltage will be, so this is R4 plus minus and this is called as the resistance R5. So like this way also we can shift here. This kind of shifting the voltage source, we are going to call it as a E shift you are going to call. E shift you are going to call. So this will be helpful whenever the circuit, it is not possible when the current sources or voltage sources are there among the many resistors like this, we can make use of this concept. So the other kind of shift which is called as the I shift you are going to call or the current shift we can call here. So it is called as the I shift we are going to call here. So this will be helpful when the circuit contains the uh, complicated, the circuit will be there. For example, let us consider the resistor in which the current source will be connected like this. The current source will be connected like this, and there will be some branch will be there. And here also we have the some current source like this. So here this is the current source here. So here some more the resistance will be connected here. So this current source R1 and R2 here. This current source it is not possible to reduce here. So we can shift this one into the like this. We can shift here, and here one more part we can shift. So here the current will be shifted like this. So this is the current I. Again the current can be shifted like this. We can shift here. So we can shift the same current into the two nodes, something called, let's say this is nothing but node A, B, C. I'm going to shift towards the node B, and again I'm going to shift towards the node C. So like this we can shift. This is called as the current shift you're going to call, where we can shift the current sources. So with this basic idea, in the next session, we'll look into the perform the source transformation for the different complicated circuits, where we can reduce the different complicated network into the